Hello friends, estimating the number of clusters with Meanshift algorithm. So in this video, we are learning about the clustering method, that is your Meanshift algorithm. In our previous tutorial, we have learned about unsupervised learning. So in that, we have learned about a clustering algorithm, that was your k-means algorithm. And now we are going to learn about Meanshift algorithm. So what is the difference between both these algorithms? Meanshift algorithm is a non-parametric algorithm used frequently for clustering. So this algorithm is your non-parametric algorithm. Now what is the meaning of that? It is a non-parametric because it does not make any assumption about the underlying distribution. So that is the main difference, that it will not make any assumption about the underlying distribution. So this is in contrast to parametric techniques where we assume that the underlying data follows a standard probability distribution. So in case of parametric, we were following about a standard probability distribution, while in that case, we are not making any assumption about the distribution of your data set. So Meanshift finds a lot of application in fields like object tracking and real-time data analysis. So now what is the internal functioning of that algorithm? Let's see. In the Meanshift algorithm, we consider the whole feature space as a probability density function. Now we are not going to discuss about the distribution mechanism, but what we are doing here, we are considering the whole feature space as a probability density function. So we start with the training data set and assume that they have been sampled from a probability density function. In this framework, the clusters corresponds to the local maxima of the underlying distribution. So there are different distributions in your data set, and the cluster will denote to the local maxima of that distribution. If there are k clusters, then there will be k peaks in the underlying data, and Meanshift will identify those peaks. So there are k peaks in your data distribution, and you have to find those k peaks. So the goal of Meanshift is to identify the location of centroids. For each data point in the training dataset, it defines a window around it. Now what's happening there? For each data point, it defines a window. It's then compute the centroid for this window and update the location to this new centroid. So it will compute the centroid for that window and then you update your location of the centroid. It then repeat the process for this new location by defining a window around it. Now you have found a centroid and you will again define a window around it. And then we again compute our centroid for that window. So as we keep doing this, we move closer to the peak of the cluster. And finally we will got our peak, so each data point will move towards the cluster it belongs to. We keep shifting the centroid, also called means. So what we are doing here, we are shifting our centroid towards the peak, that is towards the peak of your cluster. Since we keep shifting our means, so that's why its name is Meanshift algorithm. So why is it Meanshift? Because we are shifting our means. Okay, so what is your means? That is you are shifting the centroid. Means and centroids both are same. So you are moving your centroids towards the peaks of cluster. So we keep doing this until the algorithm converges, at which stage the centroids don't move anymore. So finally your centroid will not move, they will not update their location, and hence it means that we have got our equilibrium position, and that is your final location of the centroid. And now we have got our clusters and the centroid of each cluster. So that was your internal functioning of Meanshift algorithm. And now we are seeing a program so that will implement that algorithm. So let's see how we can implement that algorithm using Python language. So let's see it.